screen. I would tell you not to turn off your videos, but hell, y'all ain't never turned y'all's on, so I'm not going to worry about it. What, y'all just get out of bed or what? Y'all don't want to turn your videos on? All right, so our first one is 91. Are all three of these the same? Oh my gosh, no. Two of them are the same. This one's first because it's 77. So this come out of the second review section, number 77. Number 20 in your homework on R2. The formula A, the formula is used in the medical field to estimate a person's body surface area. The formula is A over HW divided by 36, where A is the surface area in square meters, H is the height in centimeters, and W is the weight in kilograms. Compute the body surface area of a person who is 184 centimeters tall and weighs 75 kilograms. The only part you got to worry about here is sometimes you have to convert into 1 unit, but we will try without doing that first to see if we have to, because I'm looking where A is the body surface area in square meters. To me, I would think we would want to, I would think we would want to change centimeters into meters. Now, I may be wrong, but I think we need to do that. Let's see what happens. Let's take our handy dandy document cam and let's put it right here. And I'm just going to write out A is equal to the square root of HW. You got to say W, because if you say W, somebody will make fun of you. So it's W. 3,600. And we're given H is equal to 184 centimeters. 184 centimeters. So King Henry died, meters, liters, grams, drinking chocolate milk. That's supposed to be a deca. All right, we want to change centimeters into meters. So I think it said meters, didn't it? Yeah, 1, 2, 1, 2. So that's 1.84 meters. Now, I'm not saying we have to do that. I'm just saying if we get the right answer and do it using 1.84 meters, then that's what they did. The reason we don't have to change between kilograms is because there's nothing in there other than kilograms. Since you have two different, it says surface area in meters, it would seem likely to change the centimeters into meters. Now, I may be totally wrong, but we'll see. And the weight is equal to 75 kilograms. So that's equal to square root of 1.84 times 75 divided by 3,600. So I'm going to take my handy dandy calculator. I can't use this one anymore, so I'm going to have to use this one. And there's my calculator. And I'm going to take 1.84 times 75 and divide that by 3,600 and raise that to the 1/2 power. I get 0.195789. 0.195789. And I don't know what it says do. Let's go back to the question. Round the answer to the nearest hundredth. 0.196. Okay, so I don't know if we needed to change that or not. So I'm going to check and see. 1.96. So they didn't change it. Okay, you just plug and chug. So I'm sorry I led you the wrong way. I just thought it might be better to change it into meters. So they don't want it. So that's 184 times 75 divided by 3600 and raise that to the 0.5 power. So I'll do it again. So 184 times 75 divided by 3600 and raise that to the 0.5 power. There you go. So 1.96. So that was just plug and chug. Will I test you on that one? No. I would test you on compound interest if you got a compound interest problem. And I think we did one of those last week. Or I think we did. Might have been another class. Any questions on that one? Okay. Nobody's going to talk to me. Has anyone gone into what? What are y'all talking about? Okay, y'all got to, what are y'all talking about? Miss Holcomb, what are y'all talking about? Okay, nobody's going to talk to me.
I guess that person doesn't know how to join in.
Who? Morris?
Morris. Yeah.
Okay, let me see. I can try to call him in. What was his first name? Brayton Morris. Brayton Morris. Okay, he should be getting a phone call right now. Tell him I just called him, Miss Holcomb. Okay, so let's go to the next question. The next question, I got two people sent it to me, Mr. Melnick and Miss Holcomb. So ladies first, I'm going to pick Miss Holcomb. This is number 22 in your homework. Mr. Morris, are you in here?
Yeah, I'm in here now.
Yeah. Okay. When did you, now, I do know that if you're logged on to Teams, when I call, this shows up and that join button is still there. Now, my question, Mr. Morris, were you logged on and was your computer on, and were you logged on when I sent the call out?
No, so I was doing it on my phone,
Okay.
and it was just showing y'all had recorded, but nothing else.
Okay. I don't know why it didn't show up on your phone as far as the call, but okay.
Yeah, I don't know. It usually does fine, but today it didn't.
Okay, I'm sorry. Next time, say something, get in, send me a text message on Teams or whatever, and next time I'll fix it. According to Zipf's law, the number of cities in with a population greater than S is inversely proportional. Okay, first of all, let's go over inverse proportions. So pull out my handy dandy document cam. There's three types of ratio proportions. Direct variation is what you call it. There's direct, there's inverse, and there's joint. There's three types of variation: direct, inverse, and joint. Direct is y is equal to k times x. Inverse, y equal to k over x. And joint is y is equal to kx, and you can do a z or w. I'm going to do z. Those are your three basic variations. Now you can mix them, or you can just, the one thing you have to remember about variations, for those that forgot about this in algebra, is, where's my red pen? Red pen means highlight, very important. Which of these variables never changes? Anybody remember that from 109? Which of these variables, y, k, x, or z, never changes?
Y.
Well, that's a good choice, but that's not correct. K.
Is it K?
Never, yes. K never changes. And K is what you're going to solve for in some way, some fashion. So you need to put that under very important, especially if you can't remember how to do variations. Oh, Lord, the sun's getting bright. Coming in here in this breakfast room, it's like, whoo. I don't know where you are, but it's just got bright real quick. All right, now, this one says the number of cities in, so I will change the y right here since it said inverse. I'm going to use inverse. So is equal to k over, what does it say? S. So there is our formula. The number of cities with a population greater than S, oh, I'm sorry, is inversely proportional to S. That should be, I'm going to check right quick. It should be inverse variation. Let me check right quick. Yeah, N is equal to K over S. I just want to make sure I wasn't reading that question. The question, yeah, that's right. The question is I don't like the way they got it written at the N with a population greater than S. They don't need to put that in there. They just need to say, according to Zipf's law, the number of cities in is inversely proportional to S. That's all they need to say. In 2008, there were 52 U.S. cities. 52 U.S. cities with a population greater than 300,000. Okay, now you just solve for K. So we got to solve for K. That means I'm going to multiply both sides by 3,200. I'm going to do this, or whatever that number is. I'm trying to find a different color. Here we go. Excuse me. Oh, 30,000. And of course, is that 300 or 30? Sorry. And 300s cancel. And K is equal to, and I'm going to take my handy dandy calculator and multiply 300, 123, multiplied by 52. It'll be a BA number. What is that? Is that 15,600,000? Somebody help me out. 15,600,000 is equal to K. So that K is going to go back in here. Back substitute. And now we're going to get N is equal to 15,000. 15,600,000 divided by S. Oh my goodness, what's that? Okay, sound like somebody screaming. Cox, you ain't beating anybody, are you? Okay, nobody's gonna talk to me.
No, that's one of the
Okay.
problems.
Estimate the number. Okay. Estimate A, the number of cities with a population between 300,000 and 400,000, and B, between 250,000 and 600,000. So between 300,000 and 400,000, you would set N is equal, and you would divide by 300,000 and 400,000. That's the way I would do it. So here we would go, I'm going to go to another page. N is equal, that's the number of cities, and that would be 15,600,000 divided by the S, which S okay, I don't know what S is. Can anybody read that? Well, the number of U.S. cities, that's N. That's all they're looking for. So you could say N is between, and I'm just guessing, and you could say 15,600,000 divided by 300,000, and 15,600,000 divided by 400,000. Now, of course, 1, 2, 3, 4. 1, 2, 3, 4. You get 1,500 over 3. And let's see, that's 15,600. Sorry. Hold on, I'll make sure. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2. I don't know if I counted that right. Let's see. 15,600,000 divided by 300,000. 1, 2, 3, 4, 5. Should be 156 divided by 3. Y'all check me and make sure I didn't make a mistake there. And here, 1, 2, 3, 4, 5. 156 divided by 4. Three will go into 15 5 times, and 3 will go into 6 2 times. 4 will go into 15 3 times. I think I got it backwards. 3 times 4, 39. So it's between 39 and 52 states. So according to the number of U.S. cities with a population between 300 and 400, yeah, I did 300 and 400. I think I've done something wrong. I think I read the question wrong. Yeah, I think I did. I think that should be 100,000. Let me see what they're doing here. I'm gonna have to go over here and look. I think I'm reading the question wrong. We solved for K. We did that. To estimate the number of cities, estimate the number of population greater than 550,000 and subtract that number. Okay, so 52 minus 39. Let's see if that's what they want. 52 minus 39. I don't know what that is. Let's see, 12 minus 9 is 3. 13, maybe 13 states. I don't know if I got that right or not. Yep. So that's what I did. You got 39, subtract that from 52, you get 13. So now let's do B. I'll do B on another problem. I'll show this again. Let me go ahead and write it down. N is equal to 15,600,000 divided by 5, or divided by S. And I just put N between, and maybe I should turn it around, but it doesn't really matter. That's going to be between what? 250,000 and 600,000. Hopefully you see what I'm doing. I hope you understand what I'm doing. Now, of course, we can't just say that. We got to put it in here. So that's going to be 15,600,000 divided by 250,000 N, and then 15,600,000 divided by 600,000. And here I got 1560 divided by 25 less than N less than 15. And 1560 divided by 25, 1560 divided by, turn it on, 1560 divided by 25 is 62. So 62 minus 15. And yes, this is a lower population, so a lower population would be more states or more cities, whatever it's asking. And that would be 62 minus 15. I don't know if they want to round this up to 63 or not, but 62 minus 15, I got 47. 62 minus 15 is equal to 47. Now, it may be 48 or 49 or 46 based on how they rounded that decimal, but I got 47. Okay, probably that. Let's see what they got. Might be 48 or 46. I got 30. Must have done something wrong. Did anybody get 36?
Nope.
Well, they're going to ask 15,000 questions here, but I've never seen a question like this set up like this. That's why I'm checking it. I'm not going to sit here and lie to you. Sometimes I have to have help too. I know y'all think I'm perfect, but I'm not. Did we get 15,600? Yes, we got 15,600. I'm just making sure that I did everything right. $15,600 divided by 400.
Hubert,
I'm going through everything. I'm going through the first part for those that I'm going through this part. I'm making sure I did everything right. So 15,600 divided by, I got 52. Let's see, 15,600 divided by what? 400,000. I got 39. So that should be 39. And what do we get? There we go, 13. So we did that right. But I might have something. Did somebody say something? Did you find out something while I'm talking?
I think it was 26 instead of 15 for the 15,600,000 divided by 600,000.
Okay. Well, why did I cancel out? Oh, I can't cancel out the 6. That's why. Oh, gosh. I know what I did wrong. Oh, gosh. That's just, I thought that was a 0, or I must have just had a brain bubble. Right here, I see it. You're talking about right here? I just got happy, and I just said 0, 0, 0, 0, and I just canceled out that 600,000. This should be 156 over 6. Is that what you're talking about?
Yes.
Thank you. Who said that? Who helped me out there?
Abrams.
Miss Abrams, thank you very much. 156. You're not weaned on a pickle, are you? Divided by 6. And that's 26. And 62 minus 26. So I had the problem set up right. I just screwed up the math. Sorry about that. 62 minus 26. 36, is that what they got? Yeah. Thank you, Miss Abrams, for not letting me go through the whole thing. The rest of y'all suck because y'all would probably let me go through the whole thing trying to find that error. Thank you, Miss Abrams. You get an A for the course. You don't have to come back. I'm just kidding. All right. So hopefully Miss Holcomb, where's Miss Holcomb and Mr. Melnick? Does that help out?
Yes, sir. I also have another question about that.
Yeah.
So for the part A, I get the answer by dividing 52 by 400,000 and then multiplying it by the difference between the numbers by 100,000, and I get 13. Like, I get the right answer every time.
You can do it like that, yes.
Why doesn't it work for part B, though?
Huh?
How come it doesn't work like that for part B?
Because in part B, the zeros don't line up. See, the zeros line up better on the first part than the second part. And that's just by coincidence. You got it on number 13. I meant the first part. Right. It's just by coincidence that you got it right.
I mean, it's been always working for me because I would do the question over and over again.
And when it worked both times?
It works for part A every time, but never for part B.
Huh. Let me look at it right quick. Let me pull yours up, Mr. Melnick. It may be different numbers.
I think so.
Let's see what yours. Oh God. Don't you just love Tri-County Tech?
Oh.
I gotta get out of everything. I gotta get out of everything just so I can go back in my email. So frustrating. Once it logs you out that second time, you can forget. You got to get out and go back in, and you got to get out of your Google and everything, unless you want to go through and reset your cookies and all that. And I just don't feel like doing it. So hold on a minute. Let's do the second one because evidently it must be a little bit different. 130, and that's Mr. Melnick. Let's see what these two look like. All right. So this one is the same setup. So N is equal to K over S. And the first initial setup in 2008, there was 52 cities that had a population of 350,000. So 350,000 times 52 is equal to K. And I'm going to take my calculator, and 350,000 times 52. And that's 18,200,000. Therefore, N is equal to 18,200,000 divided by S. So N is equal to 18,200,000 divided by S. And they ask, according to Zipf's law, the number of population between 350 and 500. So 350 and 500. So N is between 350 and 350,000 and 500,000. And 18,200,000, 18,200,000. Now just do the zeros, Hubert. 1, 2, 3, 4, 5. 182 over 5. 1, 2, 3, 4. 1820. Oops. 1820 divided by 350, or 35. So I'm going to take my handy dandy calculator, and I'm going to take 1820 divided by 35, and that gives me 52. Now I'm going to get to your question in just a minute, I hope, Mr. Melnick. I'm just trying to do your problem first and see what I get. 182 divided by 5 gives me a 36. So I'm going to subtract 52 minus 36. I get 16. Okay, and I think that's the answer because there's no red mark there, so that must be the answer. Now I'm going to do the same thing. N is equal to 18,200,000 divided by S, and that's going to give me, on this side, N is greater than and less than 250,000. So that's going to be 18,200,000 divided by 250,000. So 1, 2, 3, 4. So that's 1820 divided by 25. And over here, we're going to have 18,200,000 divided by 700,000. (182/7). So we've got 1820 divided by 25. I get 73. And 182 divided by 7. 26. And 73 minus 26. 47. So I'm going to check 47, and then I'm going to ask you, what did you do? Now, what did you do, Mr. Melnick? Tell me what you did again.
For part 1, all I did was, let me scroll back up. So I take 52 and I times it by 500,000 because it's between 350 and 500, and then I take that answer and I divide it by the difference between the numbers. So 150,000, and I get 16.
You took 52 and multiplied it by 350,000.
No, by 500,000. Sorry.
Yeah, that's what we're doing basically. If you look right here in the initial problem, well, I took 350,000 and multiplied by 52. You said you multiplied by 500,000.
And then after I got the answer, I multiplied it by the difference between 350 and 500, which is 150, and I get 16. I get the answer every time.
And you got 16 and 47. You got 16 and 47.
No, it never worked for part B.
Yeah. I can't tell you why it doesn't work for part B, but I can tell you if you take 52, and this is kind of hard to see because I can't see what you're doing on paper. Okay. 52, and you multiplied it by 500,000 and divided by what?
150. The difference between the population size. So between 350 and 500.
Yeah, I'm looking to see.
I just thought it was weird.
I don't know exactly why it came out to be 16 and why it's not giving you the other one. But I know this problem is centered around variation is what it's centered around. That first problem I showed you, hold on a second. This problem is centered around this. It's centered around variation. So even though your problem works the way you're doing it, Mr. Melnick, for part A, evidently that's fine, but it's not going to work every single time because they want you to use the inverse variation.
Yeah, I don't know how to do that because they didn't let me have question help.
Okay. Well, let me ask you this. Do you remember this from algebra?
Honestly, not really.
Okay. Well, that's a good thing we went over. And how many of you don't remember or had to be refreshed on this? Let me see a virtual hand. How many of you had to be a little bit, knock the cobwebs loose on these? Keep them up so I can see. Yeah, a lot of you. Well, I see quite a bit of you finally. Some of y'all went back to bed, but I understand. All right, you can take them down now. All right, what was the last thing that we went over as far as composition of functions? Did we go over composition and vertical line test and all that good stuff?
Yeah, we did.
Okay, let me look and see what is next. Unfortunately, I'm going to have to pull up my lab's math again, because when you work at Tri-County Tech and then they set the cookies to kick you out, unfortunately, you have to get out of everything. So what I'm going to start doing, I'm going to start using my Firefox to go into My Labs Plus, and that way when I have to get out of this, why is that there? That shouldn't be there. Okay, whenever I have to get out of the ancient Tri-County Tech stuff, I won't be messing up my Labs Plus. So I'm gonna start opening up My Labs Plus into my Firefox. Isn't that awful? I've got to do something with this because Tri-County Tech. Oh, shut up, Hubert. Y'all just don't know. If y'all knew what I've had to do just to be able to, oh my Lord. Okay. This has been doing this all morning. Has it done it with y'all? Giving you that sorry we're
Every so often.
yeah, look at there. All right, I'm going to Firefox. No, what I'm supposed to do is email y'all and ask y'all, tell y'all that it's not up and I can't do my homework. That's what I'm supposed to do, right? Yeah, Hubert, that's what we do. I know. I believe y'all hate me. Is that what it is? Because if it is, I can run out and get some smokestacks for my pickup truck and it'll make me feel better about myself. Ain't that what you're supposed to do now when you pick up trucks? No, you're supposed to make them squat in the back. That's what you're supposed to do, right? That's not right.
Hubert, is your truck squatted?
Yeah, I got a squatted truck and it's got smokestacks on it too. My Lab's math. That way I feel real good about myself. There we go. Now let's see if I can get on. I hope it remembers my password because I don't remember it. Thank goodness. 1:30. I'm sorry about this, y'all. Can't get out of the grasp of Tri-County Tech's ancient ways. I'm just going to go to the next section. Y'all have to help me out. I believe I went over R2. So now I'm going to go over, what's the next, R4?
I think so.
Has anybody got their outline? He said he thinks so. I think so too. But has anybody got an outline? Everybody should have their outline in front of them. Can tell me, is it R4?
Yes, R4.
Okay, thank you. Let's see what R4 is. Why do I have to open this with PowerPoint? You know to open it with PowerPoint. Why do I have to tell you? Oh. Russia, Russia, Russia. Functions, graphs. Okay. Let's see what we got here. Oh, yeah. Let's get with our old friends, slope and y-intercept. Y, yeah. Let me see. Keep going, keep going, keep going. Okay, slope. Okay. All right, this is kind of review out of Algebra 1. So we're going to go ahead and I'm going to go through and give you a quick rundown of graphing and slope. And then we're going to move on probably Thursday. We'll probably finish the review section Thursday. So try to get through with as much homework as you can by Thursday and try to send in, because the review section is pretty much up to y'all, but I'm just helping along, and Thursday will be my last day kind of helping along. So here we go. Slope is equal to delta y over delta x. The change in y over the change in x, which means y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That is slope. The point slope equation. Somebody tell me when you know to use the point slope equation. Anybody know? Whenever you have a what? A point and a what?
Slope.
Thank you, Mr. Melnick. I appreciate you interacting. One day you're going to have a nice office. It's going to be big and, you know, going to have a nice desk and everything. Rest of y'all are going to be at the end of the hallway for Mr. Melnick, and you're going to be in a closet that was transformed into an office because you don't interact with people. All right, so y minus y sub 1 is equal to m times x minus x sub 1. And that is the point slope equation. Now, those two things right there, you need to be fluent with. If you're like, I remember a little bit about it, you're going to fail this class, okay? So you might as well go ahead and get reviewed on it and get fluent with it. Let's go ahead and do one. 3, 4, 8, and 2. No, 8 and 6. All right, I want you to find the slope, and then I want you to give me an equation for this line. So it goes through, let's see, this is in the first quadrant. 1, 2, 3, 1, 2, 3, 4. 3, 4, 5, 6, 7, 8. That's 4, 5, 6. So there's the line. And I want you to give me the equation of that line. Which way do we read?
Left to right.
Unless you're from the Middle East, Masalama. If you're from the Middle East, I think that means go in peace or hello in peace or something like that. They just told us to say that when we were in Kuwait City. After the breach, they said, just say Masalama. Masalama, something like that. I think it means go with God in peace or something. You got to say Allah Masalama. I'm a Renaissance man. All right, so x sub 1, y sub 1, x sub 2, y sub 2. That's interesting, Hubert. You're from South Carolina and you know how to speak Arabic. Yep, it is. It is. It's just amazing. Appreciate you interacting with me. Y'all suck. All of you are going to be in a closet, except for Mr. Melnick and maybe Miss Hollister. I think Miss Hollister will have a nice office one day.
Yeah, you gave me my office last semester, so
Okay, good.
I'm good to go.
Okay. See, you're going to have a very fluent career because you interact with people. These people that are weaned on a pickle, they're going to have a hard time. Although some people in this class are weaned on a lemon. I just can't get anything out of y'all today. What do y'all do? Conspire and say that you're not going to talk to your math instructor? Is that what y'all do? Yeah, that's what we do, Hubert. No, that's not what we do, Hubert. Y'all realize that the more you interact, the faster the class goes by. Y'all know that, don't you? Yeah, we know that. We're just being stubborn. Well, that's fine. You're going to have a resume with a lot of jobs. Worked here from 2 months. Worked here for 6 months. Y sub 2, M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. If you walk into my office 10 years from now, and I'm still alive and teaching, and you ask me to find the slope of a line, you're going to see me do these parentheses. And I have several degrees, and I even have 22 hours past my master's. Okay? And you're going to still see me draw these parentheses. Why? Because I like drawing parentheses. Why do I put those parentheses here? Anybody want to take a stab at it?
To ensure that the order of operations is done well and you can just plug them in.
There you go. Thank you, Mr. Barry. How did you know that? I tell you what, you're going to have a nice office. All right? Why do I do that? Because you're going to have 2 things that y'all hate. What are the 2 things that y'all hate as students more than anything in mathematics? Anybody want to say something they hate besides your math teacher that you don't want to talk to?
That question's a little open-ended. I feel like it's...
Yeah, there's gonna be a lot of answers for that.
There we go. How about negatives and fractions?
Yeah.
Negatives and fractions. The next thing besides negatives and fractions that y'all hate are word problems.
I think word problems go somewhere number 1.
Okay, well, that's called critical thinking, and that's because one of the reasons y'all hate word problems is because you have been coached for 12 years instead of taught critical thinking. And that, I'm not going to get into it, but you've been coached how to do tests rather than critical thinking. Anyway, we're going to plug and chug, and I'm going to plug in a 6 here, and a 4 here, and a 6 here, and an 8 here, and a 3 here. And M is equal to 2 over 5. Y'all check my math, because the little basic math is what kills you on these things. Did y'all get 2/5?
Yes.
Yes, sir.
And you feel good about yourself, so you don't have to put smokestacks on your pickup truck. All right, so I've got a slope of 2/5, and I'm going to pick. Does anybody know which point I'm going to pick? Am I going to pick this point, or am I going to pick this point?
First one?
Why?
It's just easier, in my opinion. I don't know.
KISS method. As you said, Mr. Melnick, keep it what?
Simple, stupid.
Keep it simple. I don't say the last word. I don't like. There's 2 words I don't like. One is idiot, and the other one is stupid. And some of y'all hate the word moist. I know you hate the word moist. Anyway, 3, 4. and plug and chug. Y minus parentheses equals parentheses times X minus parentheses. And again, I use parentheses. Now I realize, that some of y'all don't need parentheses because you invented the slope formula and you also invented the point slope equation and you never make mistakes. But this mortal, immortal, or whatever, this person that makes mistakes, meaning me, I'm going to put parentheses so I don't make mistakes or try not to make mistakes. So 2/5 goes here, 4 goes here, and 3 goes here. Now what? Solve for what? Solve for y, Hubert. That's right, class. Thank you. You know, I actually had somebody laugh in my class this morning. I mean, I know that's never going to happen in here, but I actually had somebody laugh in my 120 class this morning. And your answer is y is equal to 2/5 x plus 14/5. And don't you dare ask me where that 25th comes from, because you should know. I'm going to ask it, and I want somebody to tell me, where does the 25th come from?
4.
The 4. When I bring it over, I've got to have a common what?
Denominator.
Common denominator. Good. I heard Miss Ingram in there. You're going to have a nice office one day. What I do when I add that comment about the office, I let people realize that who's weaned on a pickle and who's not. Next. Let's see what else they talk about. Let's talk about R3. And I know I'm running out of time, but some of y'all will be okay. Let me go to R3 and see what they got. I mean, let's see, that was R4. Let's go to R5 and see what they got in there. Well, there we go. Yeah, this is where we get into the family of graphs. Yeah. All right. On a scale from 1 to 10, this section right here is about 107. Everybody with me? On a scale from 1 to 10 being important, this is 107. So you can expect a lot of your review tests to come from this section. All right, let's go to Google. And for the 1 or 2 that's actually going to do this, look up family of graphs. Or you can look up parent graphs. Look at there. Even got family of graphs right there. So Hubert's not making this up. And this one right here is probably the best one. Right there. Okay, I would suggest that you put this on an index card or the inside of your notebook or something. All right, I'm going to save this. I'm going to show you how to do this. Now, it takes a lot of work. I mean, it really takes maybe 3 or 4 clicks of the mouse. So for the 1 or 2 people that's going to actually, do this, it's going to take a lot of work.
Hubert, you're
see,
asking
there's-
too much of us.
Say again.
You're just asking too much.
I know. Listen, I'm gonna tell you something. You'd be surprised on how many people don't do what I tell them to. You'd be surprised. Let's go to layout. Now you don't have to do this now. You don't have to. Okay, but you can hit landscape and it kind of spreads it out. And here we go. You ready? Control V. Let's see. So far, I think I've hit like 2 buttons. And we can make that a little bit bigger. I'm going to go up to margins and I'm going to hit that. And then we can make it a little bit bigger maybe. Now, isn't that a lot of work?
Man, I'm just dying out here.
I know. Now you have to hit
So
the
much
print
work.
button. You got to actually go over here and hit print. And you've got yourself a parent graph sheet. So I'm going to leave that on there and you can maybe sketch some of these. Go ahead and sketch them. Now, what I'm fixing to show you applies to all of these graphs. I'm going to pick the quadratic, but I want you to know that it applies with all these graphs. And that's called vertical, horizontal shift, compression, orientation, and stretching. And that's going to apply to all of these graphs once you learn, and I picked the quadratic because it's the most used. Okay, so continue to write those down. And like I said, since all of you are at home mostly or at work, you might want to hit the print button and maybe, you know what? I'm going to do this for you. I'm going to save this for now there'll be 3 or 4 that printed out. Save as, let's see, 2020. And we're going to call this parent graphs I can't spell for LADers. Okay, save. Y'all know what LAD is, don't you? It's a disorder. Anybody know what it stands for? Paragraphs for LADers.
Does it stand for?
It stands for lazy attitude disorder. It's what Hubert had when he was a student. Now, there it is for all of you to use. You're welcome. Thank you, Hubert. You're welcome. Now, why do we need to know these? Because in front of every function, there's an A. Beside every function, there's a H and a K. What do you mean, Hubert? Well, when you write a function down and you have it in intercept form, it's going to look something like this. F of x, hold your pinky up, is equal to A times x plus h, quantity squared plus k. F of x is equal to A, absolute value of x plus h, plus k. F of x is equal to x plus h to the 3rd power plus k. And there's an A there, sorry. F of x is equal to A times the log of x plus h plus k. And of course, a sine of x plus h plus k. Now, when I said I was going to do the quadratic and it would apply to all of them, yes, it will. A is orientation. H is your horizontal shift. It's always the opposite. We'll get into that in just a minute. K is always your what? Vertical shift. The horizontal shift is always the opposite. It's always the opposite. And then this, let me get a highlighter. This 2 and this 3 and this log and these absolute value marks, excuse me, and this sign, those tell you what the graph looks like. So learn the parent graph, then you don't have to carry this around. And then when you see this, you know which of these to sketch out. Comprende? Capiche? Yeah, Hubert, we understand. All right, then let's look at a little bit of what we're talking about. A, we'll use a quadratic for an example. F of x is equal to A times x plus h, quantity squared, plus k. Now, before we even start, I want you to draw a BA graph on your paper right now, just like I'm doing mine. I want you to draw a BA graph, and I want it to look like this. All the way across the page. And of course, f of x is equal to x squared. That's the parent graph. That's why I got it in black. So 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, and 4, 3, and 9, well, way up here, and 3 and 9 way up here. So this parabola is your parent graph. That's what you're comparing everything to, is that parent graph. And then we will do, and I'm going to give you an idea of what to do, and I want you to do this for homework. I want you to finish filling this out. I want you to do in a red color, let's say a magenta. I want you to do f of x is equal to 2, or let's go with 2x squared. And do the chart plot, you know, I'm going to give you an example of how to do these. Negative 2, negative 1, 0, 1, and 2. And that's going to be negative 2 squared is 4. 4 times 2 is 8. 2, 0, 2, 8. And that's basically 2 and 8 is going to be right there. 2 and 8 is going to be right here. Negative 1 and 2 is going to be there. 1 and 2 is there. Made it more narrow. So A greater than 1, well, that's A right there, means that it's going to be narrow. Now, what does narrow mean? That means it's compressed compared to the black one. It's compressed along the x-axis. What is it? What's the same thing along the y-axis? Somebody tell me. It's not compressed, it's what? Stretched, like a balloon or like a rubber band. Stretched, which is stretched or stretched along the y-axis. And that's just what A tells you. Now, I'm going to give you about 5 or 6 other functions, and I want you to graph them all on this same graph, because I want you to see what's happening with the H's and the K's and the A's and all that. So in the green color, I want you to do f of x is equal to 1/2 x squared. And you're going to use -4, -2, 0, 2, and 4. When you do a fraction, you always do multiples of the denominator, always. Okay, and then I want you to do 2 or 3 more. That function, I mean, that fuzzy, it looks like it's not focused. I guess it's focused. All right, I got to hurry up because some of y'all are going to explode. I'm going to use an orange. Y is equal to, or f of x, I'm sorry, x plus 2 quantity squared. And then in a purple color, I want you to do y is equal to x plus 2 quantity squared minus 1. And then in a red color, a dark red color, like a red, I want you to do y is equal to -4x squared. So that's 1 with the black, 1, 2, 3, 4, 5, 6. 6 graphs I want you to have on that graph paper before Thursday. Also, I want you to continue to work on R2 and R4. Right now we're on R5, I think. So, and this one is the one that you're going to be tested on the most. So you better make sure you do this little exercise I'm giving you, okay? All right, any questions? All right, I've got to run to the Anderson campus to meet with the IT people and see why they screwed up everything. So I'm going to have to get out of here quick. Did anybody come in late? Did anybody come in late? I'm going to check right quick with the roster right quick. Turn off the presentation and turn off the recorder. You are responsible.